which we use some coolants to remove that heat from the engine.
No, I am asking from which stage of the engine the air is tapped and given to the aircraft cabin so that passengers are kept warm. Otherwise, outside the temperature, no, at what altitude does the passenger aircraft fly? What is the temperature
Around
outside?
11,000 meters.
So, what is the temperature outside?
It is very less than the Earth atmosphere.
Correct. So, how is the temperature given to the normal temperature is maintained inside the aircraft, inside the cabin? Okay, if you are not knowing, okay, you
Sorry,
brush
sir,
up
I am
on that.
not aware of it.
Right. So it is taken from not from the combustion chamber. Combustion chamber temperatures are very, very high. It is taken from third or fourth stages of compressor. From there, tapping is taken. At fourth stage itself, the temperature is quite high. It is taken there and then taken to that. Okay. How is it that, the pilot's, the windshield is there, no? Where he is seeing outside.
Yes, sir.
How is it maintained? How is that, he is able to see the visibility? Otherwise, there will be snowing, no? How is it maintained? What is the system used there? Okay. These questions are invited because you have given the answer as refrigeration is what you're doing. So now I will come back to your thing. Which is the subject you like, aerodynamics or structures or propulsion?
Structures.
Structures. Sir, Ilan sir, you can take over and ask her. Ilan sir? Okay. What is Hooke's law?
For a material, when the stress is directly proportional to the strain, this is called Hooke's law.
Ilangavan sir, you can take over. Ilan sir, you can unmute. Yeah, you can unmute, sir.
Your aerospace structure means all the fundamental has to be known. You know what is Bernoulli's equation in aerodynamics?
Yes, sir.
What is that?
Pressure P plus V square by 2 plus GZ P by rho plus V square by 2 plus GZ is equal to constant, which means the mechanical energy across the streamline is constant.
What is the formula for mechanical energy? This is the way Bernoulli's equation you have to tell. Bernoulli's equation relate to energy or pressure?
Energy.
Energy. Okay. You can say dynamic pressure or we are talking in terms of pressure. Oh, I am not worried that because I want to ask what is Euler-Bernoulli's beam equation? Like Bernoulli in aerodynamics, there is a Bernoulli equation in beam bending also there, structures. Okay, what is Euler-Bernoulli's beam equation? You remember? It is ordinary bending equation.
Okay. Yes,
it is ordinary bending equation only. Okay, and that sigma is equal to
M by U.
Yeah.
M by I is equal to sigma by Y is. Sorry, sir.
I say same thing. This is a bending stress equation. Sigma is equal to My by I. But we'll answer it. Sigma stress. You are a successful. A sigma is 3-dimensional or 2-dimensional or unit single dimension. A stress in a body, in a aircraft or a missile or a rocket. A stresses are In 3-dimension or single dimension?
In the aircraft, sir.
Yeah.
It is in 3-dimensional stresses, sir.
3-dimension. What are the stresses? Sigma X,
Sigma Y, sigma Z.
sigma Z. Like the movement also 3-dimensional, correct? M about XX,
Yes.
M about YY, M about Z.
M about Z.
Right? Like coordinate also X, Y, Z.
Yes, sir.
Okay. Right? But you are going to telling the equation sigma is equal to My by, right? My by I. But what is the way in telling it? Correct way? You must write sigma XX is equal to My by into Z by, right? IXX like that. So you must always give the direction XX, YY, Z, because the 3-dimensional stress in the aircraft. Okay? That you must always do like that. Okay. You know what is vibration?
The rapid oscillations of structure are called vibrations.
Vibration. Vibration
Yes,
is
sir.
simple harmonic motion, correct or not?
Yes, sir.
Yes, sir. All simple harmonic motions are sinusoidal. Correct
Sorry,
or
sir.
all the simple harmonic motion, right? All the simple harmonic motions are sinusoidal.
All
That
simple
means
harmonic motions are
sinusoidal motions.
no, sir.
Right. There will be random also. Right. There are lot
Yeah.
of other functions are there, including the Fourier. Okay. So, what is 3 elements of a vibration?
3
Elements, major elements of vibration.
major.
What are the 3 major elements of vibration? What are the 3 elements of vibration they used to call? You remember?
Mx double mass and natural frequency and
They are not elements. They are all
damping.
correct. The elements are mass, damping, and stiffness. Stiffness K, mass M, and damping is C. So, what is the relation connecting between all these 3 in the vibration? What is the relation connecting mass, stiffness, and damping?
Vibration equation.
Vibration equation.
Mx double dot plus what is the
Mx
next
double
one?
dot equal to 2 zeta omega f
Yeah. Kf is equal to.
into x dot plus kx.
What is M into X double dot? What is
It
the
is
force?
inertial force.
What is C into X dot? Velocity.
Yes, sir.
What is that force called?
It is
Damping coefficient into velocity. What is that force?
damping force.
Damping. What is the force which Kx?
It is a spring force.
Is a stiffness force or
Spring
spring?
force.
Okay. Add all forces mx double dot plus cx dot plus kx is equal to
Is equal to 0, sir.
0.
If there is no external force, then it is 0.
This is called the free vibration equation.
Yes, sir.
Okay. If it is equal to some external force, that is called
Forced vibration.
but it is equal to force, but depend upon x again. What is that force
Sorry,
called?
sir.
Mx double dot plus cx dot plus kx is equal to f, right? If it is some external, it's okay. If it is one of this quantity, x dot or x double dot, that means displacement velocity oscillation. The force, right? That external force is equal, is consist of or depend upon the acceleration, displacement, or velocity. Remember, inertial force is mx double dot. Damping force is c into velocity x dot, right? Coefficient into velocity. And lastly, displacement forces is k into x. So acceleration, velocity, displacement combined in this side. This is it. Fx also depend upon x double dot, x dot, and x. What is this phenomenon called? Instead of the external force depend upon some other quantity, it is depend upon the same x dot, x and velocity. What is that phenomenon called? That means
I do not know.
this is called self-excited vibration.
Yes, sir.
So it vibrates, excite by itself. Okay, it is self-excited vibration. It is called aeroelasticity. Right, you have done that vibration. If the force is it is excited by its own displacement, velocity, and everything, then it is called the aeroelasticity. For example, in a wing, wing is what is a, let us say alpha. There is a wing is there. Wing has an inertial force and stiffness k is there. And small air damping and some c dot also there. Forget about that. When the angle of attack, there is a lift created on the wing, correct? Agree?
Yes, sir.
Yes. This lift again rotate the wing.
Sorry, sir.
So the created lift is twisting the wing. Right, pulling it, no? The lift, additional lift created, it will give additional angle of attack. So additional angle of attack will give additional lift. That additional lift also again give additional angle of attack. This is called self-induced vibration. Alpha increases, right? The lift increases alpha. Again, alpha increases lift like that until some equilibrium, depend upon which is stopped by the stiffness of the wing. Okay, that's called the rigidity.
Okay, sir.
So this is called the aeroelasticity parameter.
Yes,
right? Because your structures you are telling. That is the reason why I am asking. What is the forces acting on a rocket or a missile?
Sir?
What are the forces acting on the rocket? Let us say PSLV, GSLV is going. Okay. What are the forces acting on any rocket?
Forces, thrust
Right.
force.
Sorry. Okay.
And
what are the forces acting on a rocket? Like a aircraft. What are the forces acting on the aircraft?
Forces on aircraft, sir. Lift force, inertial forces, drag force, thrust, and in the fuselage, pressure forces.
Forces overall acting on the aircraft. Yes, as you said, a fuselage is the internal pressure.
Yes, sir. Overall, we can classify them as aerodynamic forces and structural forces, sir.
Aerodynamic forces, structural forces, thrust. Aerodynamic forces are two, lift and drag. Thrust is one, propulsion, right? Propulsion force is only thrust.
Sir.
And weight is the inertial force.
Yes, sir.
Right. So lift support weight in the aircraft.
Yes,
right.
Sir.
What support weight in the rocket? Balanced, not support, it is called balanced. So weight force are balanced by
thrust force.
By the thrust. Okay. Right. So this is what happening in the rocket. So in this, there is another force is there which we are not controlling. That lift force. There is another force is there. We are not discussing in the aircraft also it is there, the rocket also there, missile also there. One important force. Apart from this four forces. Can you think of the forces? One force which is very, very important, maybe small.
Sorry,
Right?
sir.
So now think, what is lift? If I create a lift in the rocket, which force is opposing the lift?
Opposing the lift.
Yeah,
Drag
thrust
force.
is, yeah, drag. No, drag is always perpendicular to lift. There is undoubled
Yes,
that is along the wind velocity direction. Always remember,
yes, sir.
L is perpendicular to the wind velocity, drag is along the opposite direction. Okay. So thrust and drag added, drag and weight added will be supported by lift. Thrust. Lift is supported by, balanced by which force?
Lift is balanced by weight, sir.
No, in the aircraft, in the rocket. Already thrust
In
is supporting the
rocket.
weight.
Sir,
Can
you're
you
asking if the rocket lift is supported by what?
by which force? That is by control force. Right. Now there is another fifth force is entering. That is called the control force. In aircraft also it is there. To stabilize the aircraft or to trim the aircraft, to guide the aircraft or navigation guidance, it use control force. Right.
Yes, sir.
How a
Yes,
control
sir.
force is created? Most of the time, control force is created by the thrust of the rocket. So it's a part of the thrust force for control force. You know any mechanism for that? How a rocket is controlled?
Uh, Using the thrust vectoring,
Very good,
using
very good. Exact,
systems.
very good, very good, very good. Thrust vector control. Engine gimbaling of
Yes, sir.
engine. So these are the forces which are thrust vector control. Okay, good. And okay, satellite you will be get confused. Don't worry. So this is a set of forces which you will be very. Okay. Now what is composite? What is the advantage of composite?
Uh, Composite is a material with a mixture of different materials,
Hmm.
which are which are not mixed with the molecular level, but they are laid one upon
No.
another, or they are
Just
arranged in a
what
format such that.
define a simple definition. What is composite material? What are the
Sir,
two major elements of a composite material?
fiber and
Other materials,
matrix.
okay. Why we are putting composite materials plural?
Because we
So what
use
is that?
more than one material in the
What
making
is
of
that?
composite.
What is that? What is that? Two
We
categories we are
use
using.
fiber,
Ah,
fiber and composites,
fiber and
fiber and matrix.
correct. So now we understand fiber. So there is a one. This is called a composite. So okay. So your refrigeration, right? What is the temperature? In a, can you plot a temperature curve along your turbojet engine or a gas turbine engine? Yeah. What is the temperature? How it varies from along the axis of the any jet? How will you plot any jet engine?
Can I plot, sir?
Yeah, plot and show. I think Balakrishnan sir will tell correctly. And this area, the temperature I want. Where you are in the refrigeration, no? What is the temperature? Like a velocity, pressure, and I want the temperature along the axis of the gas turbine or anything.
Sir, can you see this? Hello, sir. Hello.
Others are not seen. Are you able to hear?
Yes, sir. I'm able to hear.
I think others, I think not the Telanga one. I think this you have to, but the combustion chamber, no? Combustion chamber, there will be sudden temperature addition. Combustion chamber. That you have
Yes,
not
sir.
mentioned in this. So combustion chamber, at that point there will be
Yes, sir.
heat addition and temperature will increase. That is not there in that sudden increase. Otherwise, it looks okay. So even at the end also, it will not go to the free steam temperature. The exhaust temperature will be more than the free steam temperature.
Yes, sir.
Okay. Let me wait. Let us wait for them to 1 minute. And I think Dinesh also not seen, no? Dinesh also not there.
Everyone is there, sir.
But not seen.
Seen the users.
Ilangavan sir is there. Hello, Dinesh? Dr. Dinesh? No, not there. What we will do, we will disconnect and connect.
Okay, sir. Can I?
Better. The others are not there.
Okay, sir.
Ilangavan sir? Balakrishnan, I think we'll disconnect and connect. Better disconnect and connect. Okay?
Okay, sir. Hello.
You are able to hear me, Balakrishnan? Yeah.
Yeah, sir. Kindly.
Yes, sir.
Yeah. So you showed the temperature distribution. It is okay, but what is the temperature at the turbine entry?
Yeah, sorry. No, it is okay.
What is the temperature at the turbine entry? What is the turbine entry temperature?
Around 1200 Kelvin.
1200 degree Kelvin or 1200 degree centigrade?
Sorry, sir. 1200 degrees centigrade.
Centigrade. So, what are the cooling adopted in a turbine blade? What is the turbine blade?
Yeah.
What are the cooling done in? How is the cooling achieved in turbine blade?
Impingement coolings or transpiration cooling using a coolant, and that is all I can recall, sir.
There is no coolant at that place. No coolant will work at 1200 degrees centigrade. So there are different methods are there. Have you heard of the paint?
Sorry, sir.
External paint will be there, no? What is the
Yes, sir. Heat
what is the coating
exchanger.
given? Coating is one. Then inside there is a what's the turbine blade? Is a hollow blade or a full blade?
Sorry, sir. Inside?
Turbine blade, whether it is a hollow blade or it's a full no hollow. This thing is there. How is
It
turbine
is a
blade made?
hollow blades, sir.
Huh?
It is hollow blades.
It's a hollow blade, correct. So it's a hollow blade, so that cooling air will be given through that. Okay, no coolant. Cooling air will go through that, right? So what is how is what is a single crystal blade?
What is single?
Crystal blade.
Sorry, sir. I'm not aware of it.
Okay, because in turbine blades, to withstand the high temperature and then to minimize damage because of the temperature, it is single crystal castings are made. So go through that. What is a single crystal castings? Find out about that. Okay.
Okay, sir.
So this is where in the propulsion, if you are talking about high temperature, the turbine blade is the one which is at highest temperature. Then the cooling methods which are there, I told you, inside the hollow, the thing is there through which cold air is passed through, and externally there are paints which will applied which will cool down the turbine blade. And turbine blade, they are made from single crystal castings to withstand such high temperatures. Okay.
Okay, sir.
Single crystal means when you're cooling the blade, when you're making the blade castings, you'll cool it in a molten aluminum or molten tin. As the temperature goes down, uniformly it will come, so that there won't be any grain boundaries outside. So it is called a single crystal. There won't be any grain boundaries. So that
Okay,
is
sir.
what is. So you have to go through all that. What is single crystal? Now, what is pressure ratio? What is pressure ratio in a turbojet engine? What is the pressure ratio?
Sorry, sir. I'm not aware of it. I'll look into
Okay,
it.
and go into that. And how many stages a compressor will be there in a modern jet engine?
We'll have a high pressure compressor and a low pressure compressor.
How many stages?
It's around 8 to 9 stages.
9 stages. Okay. What is vector thrust?
Sir?
What is vectored thrust?
Vectored thrust.
What is the thrust thing?
In
What is it
rockets, we
used for?
use. Sorry, sir.
I'm talking about a modern jet engine.
In jet engine, vectored thrust. Sorry, sir. I'll look into it.
We'll go through that. Yeah. Right. Now, Tirthamalai sir, you can take it. Hello.
Are you able to hear?
Yes, sir.
Okay. So now let us some aerodynamics, some simple things also we will learn. This particularly for supersonic, because you are going to join DRDO. Supersonic. What is can you tell what is special about supersonic? Anything, some special characteristics in supersonic? Or what is supersonic flow?
If the Mach number is above 1, which means the velocity is greater than the speed of the sound, it is called supersonic, sir.
Okay, in supersonic, what is happening, which is not there in the subsonic flow?
The information, the downstream information cannot be reached to stream, and there are a formation of shocks which are not there in the subsonic flows.
Okay.
And
What is shock? What is shock?
Raise of pressure across a boundary is called shock.
Not boundary, across the top. There will be sudden jump. The properties, there will be sudden jump will be there.
Yes, sir.
Okay. So, what are the properties? Suppose you take total pressure.
Yes, sir.
Total pressure after the shock, it will be reduced or increased.
It will reduce, sir.
Temperature, total temperature.
Total temperature remains constant.
Why?
It is because the enthalpy remains constant, so the total temperature remains constant.
The total temperature is a measure of the energy. Okay,
Yes,
total
sir.
temperature is it is having all the energy components. No, it is a measure of the energy. So that's why the energy is conserved.
Yes, sir.
Okay. And what about the static pressure?
Static pressure will increase, sir.
Temperature, static temperature.
Static temperature also will increase.
Mach number.
Mach number will decrease to subsonic flows if it is a normal shock.
Public shock.
Oblique shock, there are some cases where the downstream Mach number can be greater than can be supersonic.
Okay. This for rocket, no, for missiles and rocket. What type of propulsion they use it?
In rockets, we have different propellants like cryogenic propellants.
Yeah, what are the type of propellant? He's asking.
Propulsion system. You can you tell what
Yeah.
are the type of
What are
propulsion?
the propulsions depend upon the type of propellant they are using. What are the type of propellant systems?
Yeah, we have solid, liquid, and cryogenic propellants, sir.
Solid.
Okay, mostly
Mostly in the first stages,
Sound is breaking.
your voice is breaking.
Yeah, voice is breaking.
Are you able to hear?
What happened?
I think it's
hello.
not getting signal. Yeah, we are able to hear.
Sir, can I turn off the
Okay,
camera
continue.
because my
No problem,
sir,
no problem. No problem. Go ahead.
in the rockets, in the first stage or booster stages, we generally use solid propellants, sir. And in the above stages, we use the liquid propellants. Liquid propellants are preferred.
Why you are going for staging? Why you have to do? You can put everything together and fire, no? What is the advantage of stage?
Then there are
Why
solid
you have to have
propellants,
multiple
liquid
stage?
and solid propellants, liquid propellants, and cryogenic propellants are used in the rockets, sir.
No, okay. Why staging? You can use solid and you can put everything very big motor and fire it. No?
Yes, sir, but
Stand fire, agent stage. What is staging?
it is to reduce the propellant is over. We can leave that onto the earth, and then our weight will decrease. So on the whole, the overall weight will decrease when we use the staging, sir.
Which will reduce?
Weight of the rocket.
Overall weight.
Yes, sir.
Overall weight
Overall
means
use
what is
of
the weight of
propellant.
Again,
what is the weight
Using
of
of
GSLV?
ah,
Or yeah, the LVM3 also. What is the weight?
mm, weight of
Tell me
rocket,
any
sir.
rocket. Yeah, any rocket you take it, GSLV or LVM3 or PSLV. What is the order of the weight?
Sorry, sir, I'm not aware of it.
Okay, right. Kindly go through. We are going DRDO. You got weight, dimension, propellant. Okay, type of control system. What is the material used in the fabrication? What is the
Yes, sir.
temperature ranges, pressure, velocity? What is dynamic pressure? Okay, what is the when the bending moment will be maximum? When the load will be maximum? What is alpha max? What is Q max? What is Q alpha max? Okay, all these things. What is a thrust curve? All the things you must throw because you are going, you must know about rockets and this. A typical rocket, you take it and use it. What are the type of structures they are doing? Composite, honeycomb structure, beam, shell, plate. So all the things you must be able to have some small idea. Okay,
Okay,
before
sir.
going to. Okay, wish you best of luck. I hand over to next person. Thank you.
hello?
Hello, sir.
Yeah,
Ah,
next
are you able
person.
to hear?
Yes, sir. You're
Ah,
audible.
okay. Now you are going to DRDO. What DRDO does?
It does missile technologies and aircrafts for the military sections.
That's all. What do? You go through
Uh,
that website. Okay, there
okay,
are they
sir.
develop material, electronics, radar. LRD is at Bangalore. They develop radar, and tanks developed in CVRD, Chennai. So you have so many things are there. They're developing. Okay.
Okay, sir.
Okay, because you are aerospace. What are the types of missiles?
Solid propellant missile.
No. That is
It's
not. That is a propulsion. That is propulsion.
What type of
Types of
missiles?
missile.
ballistic missiles.
Hmm.
Then
What is opposite to ballistic missile? Okay,
sorry,
what is
sir, I'm
ballistic
not able to
missile?
recall.
But you are
The
going to
ballistic.
DRDO, no? You should prepare all those things. Huh?
Yes, sir.
So, okay, what is ballistic missile?
The missile which uses the rocket propulsion
No.
technology is ballistic
All
missile.
missile uses rocket propulsion only. Most other missiles.
Okay, sir.
Jet engines are used by few. Mostly all are rocket only. I think you have to brush up those things. It is very much important for DRDO going for DRDO.
Yes, sir.
Ballistic
Okay.
missile, just there is no control. Mostly it will be, they will inject it and then it will go in the ballistic mode. Ballistic, that name itself goes to ballistic. Other one is a cruise
Okay, sir.
missile. So cruise missile
Yes, sir.
continuously it go in the cruise mode. Okay.
Yes, sir.
Can you name some few missiles? DRDO missiles.
Um, Agni,
Agni,
Dhanush, Prithvi, BrahMos.
Dhanush. Where from here the Dhanush? Dhanush also there, but I don't know how you came to know that Dhanush. Dhanush,
uh, uh, Trishul,
Trishul,
and Pralay,
Pralay, good.
and BrahMos missile.
BrahMos.
That is all I can recall,
Okay,
sir.
good. Okay. Out of this Pralay, what type of missile Pralay?
It is a solid propellant missile.
Whenever I ask missile, there is a classification of. Have you read the classification of missile? Where you
No, sir.
would never.
I haven't.
Can you tell me what is how the missiles is classified?
Mm, sorry, sir. I'm not aware of it. Of the
Missile is classified
classification.
from classification. They have done it from where it is a platform. It is launch platform and target. It is classified like that. Surface to surface, surface to air to surface, air to air, then underwater, other things are. These are the four and other things also there. Okay.
Yes, sir.
Agni, what type of missile?
No, sir. I'm not aware of it.
You brush up. These are all very, very important and they are all expected. When you go for DRDO, you should know what they are doing.
Yes,
Understood,
sir.
no? Okay. I think have you okay, control, if you take a control, no? Control. Are you what is your BTech, what is your project?
It is terraforming of Mars, sir.
Terra?
Terraforming of Mars using alpha seeds.
Using alpha?
Alpha seeds. We have developed a mechanism to terraform Mars using alpha seeds.
Alpha seed or seeds?
Seed.
Seed. Okay. You
Your
are talking
BTech
about
is
the
in
agriculture.
which discipline? Aero only?
Yes, sir.
Yeah, under terraforming is telling. Okay, compare the atmosphere of Mars and Earth.
Sir?
Compare the atmosphere of Mars and Earth. See, if you want to terraforming, you must know the weather condition, no? Right?
Yes, sir.
Yeah. So what do you kindly compare the Earth atmosphere and the Mars atmosphere? What is their content? Gravity is, yeah, the gravity also
is very low. Gravity is low on Mars.
Gravity is
low on Mars.
Don't say low, high. You tell the figure. If it is 1 G at Earth means what is the G there at Mars?
Sorry, sir, I could not recall them. I'll brush it up.
What is the temperature at least? What is the temperature range?
It reaches up to 20 degrees centigrade in the summers and up to minus 20 degrees during night and in the afternoon in the noons.
Right. But there is no soil. That soil, the seed can grow. You can see the Mars movie also, right? Yes, first he started sowing some potatoes for the food.
Yes, sir.
Okay.
Yes,
what
sir.
are the challenges of agriculture in Mars?
Sir, can you please repeat question?
What is the challenge of agriculture in Mars comparing it?
Providing the water to the plants is a challenge. It's such a low pressure. It is
How
not.
will you manage water? How will you manage water?
We haven't done onto that, sir.
Not onto. Is the photosynthesis possible? So explain your method. You're telling alpha. What is that actually?
Yes,
what is that method?
We have planned on. We have assumed that we are availability of water, and then we have developed the mechanism where it can sow the seeds, and on the Mars compared to that of Earth, we have built a conical section that will be transferred from the that will be placed onto the surface, and then the soil will be filled into the conical sections using a screw mechanism, and the seeds will be planted into them, and
So what are the 3 levels of terraforming, or 3 types of terraforming, or 3 levels of terraforming? General, have you heard about that? 3 levels of terraforming.
One.
3 levels of types
Yes,
of terraforming, or 3 types of terraforming we used to talk about other planets possible. You heard about what is para
no,
terraforming?
terraforming is making the atmosphere breathable and living, making the harsh conditions similar to that of the Earth using the industrial applications by increasing gases on the
That's enough.
Mars.
It is that enough. Is there any additional factor comparing Earth? It is there in the Mars. You are telling -1 degree. If we have the water will freeze. How the
Yes,
planet will go? Yeah, how the planet will go. So your condition warming the planet so that water is not frozen.
yes, sir.
We need how will you do? Right.
By
It is a
increasing
cold
the
planet.
gases.
Yeah, in a cold planet, the terraforming is what are apart from that. What about the radiation, which is not there in Earth? What is the effect of
So
radiation in Mars on planet? Sorry, planet.
there are craters on the Mars where inside the underground, in which we can the radiation is comparatively less than that of the surface, with
No,
where we can use for
yeah,
the living.
this is a cosmetic radiation. It is not an ordinary resource, but source is from sun. Your valley, comparing the distance to the valley and this one is not much. So cosmic radiation, frozen water not freezing, right? So there are some 7 to 8 points are there. You call me after that, I will tell you. What are the method of terraforming? Okay, in Mars. I am interested in that. Okay, right.
Yes.
Anyhow, now you prepare the fundamentals of structures from stress strain relationship. Okay, bending, buckling, and temperature variation. Right, 3-dimensional. This one, aerospace. All the things,
Yes.
Vibration, all things. You have some fundamentals on vibration. All the things. Okay, right.
Okay.
Best of luck. Prepare all these fundamentals. Thank you.
All the best. Prepare DRDO. Go to the DRDO website, ADA website, all those things. What are the missiles? What are the types of missiles? Yes, you are going there for aerospace, and most probably you will be somebody from missile complex only. They will come as interview. They will be asking these things. Okay.
So in addition, other aircraft projects also you must be knowing there. In DRDO, no AMCA project, how is it going?
Yes,
If you see the website,
correct.
you will know some information on that. Yeah. Okay. All the best.
Next people are.
Yeah, we have one more candidate. We'll just wait for him to join. 7 o'clock he will join. So, any other thing Swathi, you want to know? Because we have Tirthamalai sir radio, Bala sir from HL, and Ellen sir from ISRO.
Sir, I would like to know the feedback on my interview.
Feedback.
Yeah,
Technically okay, but you are taking time to this one. You are not prepared well for interview. That's what. So you are roving around and searching, and the basics, some of the basics also you are not able to give proper answer. Okay. So
Okay, sir.
I think Ilangon sir is giving so many tips, but even then you are not able to pick up. Looks like that you are, I don't know, you are not prepared for the interview. So you have to put more efforts. But the basics knows, but you are not able to pick up those things. Yes, interview is only for some half an hour or 1 hour. Within that, you have to bring it. Means you have to prepare well. That is not, you have not done it. And the DRDO, because you are going for DRDO interview, you have to prepare for DRDO go to the website, what are the things and all that should come out in fingertips fast. Okay. So when is your interview
Okay.
date?
28th, sir. 29th.
Okay, you have really 5 short thing. I think you have to put a lot of efforts. Prepare it well. Okay.
Swathi, are you
Another thing which
having
another thing
content we
I
have
want to tell is, hello, if you're talking about freezing and like this, now you talked about terraforming, then all questions will start coming on that side. So you be very clear which topic you want to speak, and speak on that topic only. Otherwise, you will get into different areas, and you will get into a problem. Okay.
Exactly. Because I got
Okay, sir.
interested in this one. I'm doing research in that. Suddenly,
Yeah.
yeah, that you don't give place. Especially any
Okay.
ISR person is that definitely you'll once you told this terraforming and everything, human space flight, you will be into that. Okay, right, anyhow. Thank you.
Okay, sir. Okay. Thank you, sir.
since job is a BTech level, so Swati, it is good if they start from basics. Of course, they may ask what you are doing in IIT Bombay. Then briefly you can tell ki I started working on this. Don't tell ki I have done. Okay, if you say like I have done, then they will expect you should know like that. Okay, and did you start brushing basics from those formula sheets and concept sheets, Swati? Swati, am I audible?
I think she left. I think.
Okay, fine, perfect, no problem. So other candidate have joined Paras. Paras, can you share your webcam and introduce yourself?
You unmute first. Unmute it. Unmute it. Okay.
Hello, sir. Audible, sir?
Yeah,
Yes, yes. Go ahead. Go ahead. Briefly tell about you.
Sir, good evening, sir. My name is Paras Kumar. I'm currently working in ADA as a project assistant. My job is mainly focusing on the internal aerodynamics, especially intakes. In this, we first clean up the geometry, and by using the CFD solver, we estimate the data,
Wait,
especially.
Paras.
Yes, sir.
Don't give that much detail, okay? When they ask, tell about you. So you just tell your name, you are from which place, and where you did BTech, and currently working with ADA. That's it. Don't
Okay, sir.
go in detail. If they ask something, then only answer. Okay? So please.
Okay, sir. Okay. So, sir, my name is Paras Kumar. I I pursued my BTech from the PM College, Haryana, and I currently in Delhi, and I working in currently in ADA, Bangalore.
AD. Okay.
Yes, sir.
ADA in which division?
Sir, LC Air Force Mark II, Aerodynamic Division.
Aerodynamic division.
Yes, sir.
Okay. Then Chittamani sir, you can start.
Okay. So now I think I have seen these things. You are using the CFD for many things, no?
Yes, sir.
So you are good at CFD.
Not too much, sir, but work-wise I
How
can
many?
do.
Okay. How many years you are working in CFD?
Sir, currently 3 years over, sir.
3 years means good. I think you should be good at. Okay. What is CFD is based on what? Which equation?
Sorry, sir. Which equation I am using, sir?
No,
CFD.
CFD is
Suppose you
based
take
on what?
as a CFD, there is some equation, fundamental equation, no? What is the
Sir,
fundamental equation
continuity.
for CFD?
They are continuity equation and momentum equation.
Uh,
In momentum equation, we are using a Navier-Stokes equation, sir.
no, hold. Continuity, momentum, then
Navier-Stokes equation and energy
okay,
equation.
okay. These are all put together is called Navier-Stokes equation nowadays, no? Okay,
What,
even
sir?
though Navier-Stokes they derived that momentum equation, all this put together
Yes, sir.
it's called for CFD it's a Navier-Stokes equation. So you have continuity, momentum, and energy equation.
Energy. Okay.
Okay. So in this, you are using laminar flow or turbulent flow?
Sir, we are using turbulent flow, sir, because we are using turbulence model.
What is the difference between laminar and turbulent?
So laminar flow is like a flow is very uh, sir, can I say in Hindi, sir?
No, not. I don't think you can say your Hindi words you can use, but not for the basics, no.
So laminar flow is like in which the flow is not fluctuate very much. Like fluctuation is not there. They flow very adjacently. But turbulence flow is like fluctuation is there in velocity and pressure too much.
Okay, you are taking time varying things are there. So you go through that, and the turbulent for CFD for turbulence flow, no, lot of these things are there, no. So what they do? Have you heard of turbulence modeling?
Yes, sir. Yes, sir.
So which model you have used?
Sir, we are using K omega SST turbulence model.
Okay, in that K omega SST. What is K? What is omega? What is SST?
Sir, K is the turbulence kinetic energy.
Okay.
Omega is the specific dissipation rate, and SST is the
Okay.
shear stress turbulence model.
Okay. So why you selected this? Any reason, or have
Sir,
you done the?
there are many other models also, like K omega and K epsilon.
Uh,
K omega is especially accurate for the wall boundaries, but is not accurate for the free stream when we go above the free streams. But K epsilon is accurate on the free stream, but not accurate to the wall boundaries. So we are using K omega SST, which is the blended function of the K epsilon and the K omega. So it will give the accurate result at the boundaries also and free stream also.
okay. So you are what for you are using this one for your intake simulation,
Yes, sir.
air intake simulation. Okay. You are using it for air intake simulation, no?
Yes, sir. Yes, sir.
What type of air intake you use? This is for which aircraft? Aircraft or
Sir,
this is for which?
LCF was Mark II, sir.
LCM Mark II already already they have done it, no? What you are doing? The LCM Mark II?
Sir, LC Mark II intake aerodynamics only I'm doing, sir. Like various Mach numbers
Intake
alpha and
aerodynamics.
yes, sir.
So what is the which are the free stream Mach number you
So it's not
are
fixed.
trying?
I am doing from 0.35 like subsonic, supersonic, both I am doing, sir. Transonic also.
Okay. So what is buzzing?
Sir, buzz is like an unsteady phenomena which occurs due to the oscillation of the normal shock, or we can say that because of the shock boundary interaction.
Okay. How you are predicting?
Sorry, sir.
How you are predicting? How you are saying that it is this is the this if I do the CFD
Uh,
simulation, I am seeing there is a buzzing is there. Not there means how you
sir,
are predicting.
sir, it is predicted by the based on the sudden drop in the total pressure. When the sudden drop in total pressure occurs, then we predict it's a burst.
Okay. So you will be scanning and you will doing, or there is you are putting some other method.
What, sir?
You will be scanning. You will be scanning the total contour plot. You make it, and then now you do it.
Ah,
Contour plot you make it, and then
sir,
from that you will identify. Or you
contour
have
plot
made a
also we
separate
can make,
program.
or we can make the Excel sheet also, sir. In Excel sheet, we make the eta graph with the area, and we check the how the pressure, like total pressure drop where it's coming.
Okay. So as a air intake, what are things are expected from air intake?
Sir, mainly on the basis of work, total pressure loss is have to be less, and
Pressure recovery.
distortion
Then
have
what
to be
else?
less.
Okay,
The
then
distortion
what
have to
else?
be less. Sir,
Distortion, recovery.
buzz have to be not there,
Okay, instability should not be there. Then,
and sir, swirling is not there.
huh?
Swirling distortions.
Swirling. Okay, okay, swirling is not there. Then what else? Swirling and your this one other instability. What is the? It will be related, no?
Pulse is also not there, sir.
Distortion coefficient. When you calculate
Huh,
distortion coefficient, then wherever
yes, sir.
swirling is there, it will come out. No, normally the aircraft for engine, anybody specifies swirling and all those things. They will specify distortion only. No,
Yes, sir. Yes, sir.
I see. So these are the things. You not to go to those are all sub part of that. Only distortion coefficient, pressure recovery. One more is there important. That is you are missing. What for air intake is required? Air has to come, no? The air is measured in terms of
Yes, sir.
mass flow rate.
Yes, sir.
Required mass flow rate for the engine also, that is one of the important parameter. Okay? Mass flow rate,
Okay, sir.
pressure recovery, and then your distortion coefficient. Okay? These are
And
the
sir,
main
pulse also we
parameters.
can go.
Sorry?
Pulses.
Huh?
The pulses on the intake, like rapid fluctuation of the total pressure.
That is instability. That is actually, if it is instability, is there your distortion coefficient itself will indicate. Okay. So
Okay,
those
sir.
things, instability and other things, buzzing, instability and surging, all those things will be taken care. All those things also there,
Okay,
but these are the important. Okay. All the
okay,
instabilities
sir.
also, it will reflect in terms of distortion coefficient. Distortion coefficient will become this one. Okay. So now,
Okay.
now this uh, this aircraft, when their engine is there and then they're controlling, what type of controls are there in the aircraft? How they will control the aircraft?
Flight controls you are asking, sir.
Yeah, not the flight control, aerodynamic control. What are the aerodynamic controls?
Sir, like spoilers. You asking?
Spoiler. Okay, spoiler. What for they use?
Sir, to reduce increase the drag during the landing.
Okay, that is spoiler. Okay.
And
What
sir,
else?
ailerons,
Ailerons.
flaps.
What for flaps?
The flap is a HLD, like high lift devices, which is used for takeoff to increase the CL.
Okay, flaps. Then
And sir, one more thing we are using, which is air brakes.
air brake. What is spoiler? What is air brake?
Sir, air brake is
Air
like
brake.
during the it is also like a spoiler only, but we are not using spoiler in the Mark II. We are using air brake in the Mark II for increasing the drag.
Which one you are using?
Sir, air brakes.
Okay, they are all coming for secondary, all those things. What is the primary is? Primary
Sir,
is what is say as a aircraft, it is having how many degrees of freedom? Motion.
sir, primary flight of control is rudder.
What rudder does? Which
Uh,
control?
the rudder is doing the yawing motion,
Then what else?
and elevators, which is doing the pitching motions.
Which one? Elevator. Okay.
Elevators. And sir, rolling moment by ailerons.
Ailerons. Okay. Now, suppose this is stable aircraft. Okay.
Yes, sir.
You want to pitch up. You want to pitch up.
Yes, sir.
Aileron, how they will deflect? They will deflect downward or upward? Aileron will give
The
downward
elevators.
force or upward? Elevator will give downward force or up?
So, pitching up means you have to lift have to be go downwards. Elevator have to be go pitch up, sir.
Pitch up means force will become down or up in the elevator.
Downwards. Sir, force
Downward.
have to go
If it is
downwards, sir.
Okay, and if it is a canard control?
Sir, canard also there.
Canard, how they will deflect? They want to give
Like
a pitch up.
So cannot have to be pitched down. I think.
Yes, about CG, elevator is behind,
Yes, sir.
canard is in the front, so it will opposite
Yes, sir.
direction. It has to give the moment. Then only it will
Yes, sir.
same. Okay, so force will be opposite direction. It will create same moment. Moment will be same.
Yes, sir.
Force will be in the opposite direction.
Yes, sir.
Okay. So when so out of these two elevators, which is the rear side and the canard, which is beneficial in terms of producing lift?
The elevator and canard.
Yeah, canard, front surface, or in missile, if you take one is a canard control, the other is a tail control. Which is
Yes, sir.
beneficial?
Sir, elevator is beneficial because canard we are using for mainly for maneuverability.
No, say moment wise, both are giving same moment,
Yes, sir.
but force wise, which is aiding the lift?
Force wise, I think, sir, elevator.
Elevator, we are told it has to give downward force, no?
Yes, sir. Oh, sir, lifting. Okay, okay, sir. Okay. I thought pitch up, sir, you are telling.
So canard, whichever is in the front, that will aid the lift. So high maneuverability
Okay,
they want. That's why normally they use the canard control. So canard control immediately if you tilt it in same direction, you will get the lift. So
Lift. Yes,
it
sir.
is the that's why people are high maneuverable missiles and high maneuverability they use the canard control. Okay, understood now.
Okay. Yes, sir.
Okay. Now I think somebody else can. Langon sir. Okay. In the meantime, we will continue. This for LCA, this air intake is under the wing, no?
Yes, sir.
Under the wing. What is the benefit of this air intake keeping it under the wing? Why not push it in the front? What is the advantage? What is the disadvantage?
Sir, advantage is like it will use for the torsional, like torsion when it like bending moment when it come for the wing. So when sometime wing when moment come the wing will fluctuate like this. So this under wing will help to reduce this bending moment of the wing or fluctuation.
That will very less because that air intake weight is very less. So it will not have much inertia. But aerodynamically, you had worked on flow and all those. Aerodynamically, what is the benefit of putting the aircraft? Say, suppose wing is not there. Okay, wing is not there. Air intake is there. The angle of attack faced by the air intake, it will be free stream angle of attack. Correct, no?
Yes, sir.
But in the presence of wing, how the flow will turn, how it will angle of attack of the intake will be lower or upper?
So intake have to be like if flow strike the wing, it will vortex will come like some swirlation will come will affect the intake also.
So because of the wing, that flow to the air intake, angle of attack to the
Yes,
air
sir.
intake, it will be reduced. It
Yes,
has
sir.
already turned parallel to the flow is turned parallel to the wing. So it will be going into
Yes,
that.
sir.
So it is the flow is directed towards the air intake. So the air intake which is facing the angle of attack, it will be less. But what is the disadvantage?
The disadvantage like we have to make the wing more stronger to hold the intake.
What is structurally, aerodynamically? Boundary layer of the wing, where it will go?
As a boundary layer
The
will go
wing boundary
inside
layer
the
will
intake.
enter into the
Intake.
intake. To avoid that, they have to put the
Filter plate.
diverter.
Yes, sir.
So many other things also we have to do those things. Okay. So these are the things we have to do it in this one. Now after this one, say now it is going into the nozzle. Okay.
Yes, sir.
The flow is entering into not nozzle. So what type of nozzle they use? Jet
The
engine
nozzle we
normally.
are in convergent nozzle, sir.
Conversion nozzle. If the velocity is more,
Sorry,
have
sir.
you not heard of convergent divergent nozzle?
Sir, convergent I studied, sir.
Huh. So what is the difference between convergent and convergent divergent nozzle?
Sir, convergent nozzle is like it will converge like this thing, sir. And CD like one more divergent section we add in the convergent nozzle.
Where
But
you will use the convergent nozzle, where you will use a convergent divergent nozzle.
the CD nozzle also sometimes we used, but I'm not able to recall where.
Okay. Now I will give some this one further one. Say this nozzle, what will be the pressure, exit pressure when it is going into the atmosphere? What will be the pressure? What is expected pressure?
Sir,
It will be
exit pressure
it will be close to the
have to be
go
equal to
ahead.
the ambient pressure.
Yeah, almost equal to the ambient pressure. So if
Yes,
it
sir.
is inside, if the combustion chamber pressure or that outside pressure is high, then if it is very high means conversion nozzle will not be able to bring it down the pressure to the atmospheric pressure. There we have to use it. If the pressure ratio is high, we have to use a convergent divergent nozzle. When the pressure ratio is low, convergent nozzle will be sufficient. Okay. So normally rocket what they use, convergent divergent nozzle or only convergent nozzle? Rockets, solid
So
propulsion.
converge. So for high propulsion in convergent divergent nozzles, shock will come.
Convergent divergent nozzle shock, where it will come?
So in the divergent section.
Why shock has to come? On water,
Uh,
what condition shock will come?
because the flow is supersonic, so because of the flow in divergent section, flow is supersonic, the shock will come in the divergent section to
Whenever
reduce.
supersonic flow, shock need not to come, no? Does not mean
But
supersonic does not mean shock has to come. This convergent divergent nozzle is a isentropic process, ideally. So it will Mach
yes,
number
sir.
slowly increases and then it is going to supersonic. When
Yes, sir.
shock will form? When the
Okay, sir.
atmospheric pressure, when the atmospheric pressure is more than the exit pressure will come, or if it is less than that exit pressure, it will come. When shock will form in the divergent section?
Okay, sir.
Not okay. When it will form, and what condition? Have
Uh,
you heard of over expanded, under expanded?
yes, sir. Yes, sir.
What
So
is
it
over
depends on
expanded?
the over expansion, like when P exit is less than the P ambient,
Okay.
and P exit when greater than the P ambient, then under expansion will come.
So when it is over expanded, that exit pressure is lower than the outside pressure. To
Yes, sir.
satisfy, suppose you want to satisfy that, then shock will come. Okay. There are some
Yes, sir.
criteria also there. So it should be less than 0.4 of that exit pressure. Then only it will shock will form. Otherwise, it will go and shock will not form. Okay. So this
Okay,
is
sir.
and have you heard how that this jet control? Have you heard what are the different types of jet control?
So jet controls.
What is jet control?
Sir, I can't able to recall, sir. Jet control.
No, no. Jet control. Okay. Anyway, you fresh up. I think I will.
Yes, sir.
I'll tell Professor Balakrishnan or Legon.
Yeah. Now I said, what is vector thrust?
Sir, vector thrust is like there are two types of vectors, 2D vectoring and 3D vectoring. Like when we changing the axis of the nozzle in 2D and 3D axis.
Okay. Now you talked about air intake, and you say it's
Yes,
a
sir.
turbulent flow. Now
Yes, sir.
in a jet engine, there is a compression ratio, and the engine is and the blades are running at a very high RPM, right? So
Yes, sir.
what will be the effect of the engine on the intake?
Effect of the engine on intake.
Yeah,
So it depends. It's mainly go to the mass flow rate. Like engine wants more mass flow rate or
correct.
less mass flow rate. So sometimes when engine demands less mass flow rate and we are giving more, so it occur to the spillage drag.
Okay. Basically, engine will suck the air, or engine will not do anything.
No, sir, engine will suck the air.
Correct. So that is why now in the during. So what happens when the engine is sucking the air? What happens in the intake?
So when sir engine sucking the air, like when engine demands more, like engine demands less suck of air, but we are giving more. So sir, spillage drag will occur and frictions, sir. Maybe I'm not sure, sir.
No, now you're doing the CFD analysis, right? You will be doing it for the
Yes, sir.
different conditions, or it's only at one condition you're doing the CFD analysis of the intake.
But, no, sir. Different Mach numbers, angle of attack, and side slip.
Correct. So if you're doing for different Mach numbers, then you should be able to answer, right? Just go
Yes,
through
sir.
what you're doing there. Yeah. Because now during the transonic flow, what will be the during the transonic flight? What will be the conditions in the intake?
Sir, comparing to the others, like when we're going for subsonic to transonic, the pressure recovery will reduce. Like less recovery is there for total pressure.
Okay.
And when we
There'll
go
be
to
the flow
subsonic,
will become turbulent, right? From
yes, sir.
subsonic to transonic, it become turbulent, right? That is the main problem.
Yes, sir.
So in
And
turbulent flow, what is the safety analysis? What is the safety analysis doing there? The,
sir, in turbulence flow, we are using the turbulence model for CFD analysis.
okay. No,
Uh,
the purpose of the CFD analysis is what, to give the adequate the air to the engine, or what is the purpose of the CFD analysis?
the CFD analysis is like we're giving the solvers boundary condition at the particular meshes. So at a particular boundary conditions, we get the result.
At boundary conditions, we get the result. Say, if your CFD is showing some factors it is giving, so it is used
Yes,
for
sir.
design of the intake, or what is the purpose of that CFD analysis?
The
Why
CFD
are you told
analysis,
you are doing the CFD analysis?
the like design we got from the design team. In CFD analysis, we discretize the geometry domain into the smaller elements. At the smaller elements, we use the continuity equations or conservation equation we used to solve the result to get the result. So in this part intake duct exit, we have a AIP, which is aerodynamics interference plane, which
Okay,
is the which is at the engine face and at the exit of the duct. So at the AIP, we give the boundary condition like I am giving the mass flow rate outlet. Like we previously calculate all the mass flow rate outside the engine, which G gave to us. So at that
okay,
particular mass flow rate, the CFD will analyze the AIP boundary condition, AIP total pressure, like what the total pressure of the AIP at a mass flow rate which we are giving at the engine phase.
okay. Now, do you having the inlet vanes or not? What is the
Sir,
purpose of an inlet vane? And
inlet guide vanes, sir, in my duct is not there. Maybe the compressor is having, but in duct is not there.
Not there. So what is the purpose of the inlet vane?
Sir, inlet guide vanes is used to prevent the swirling of the non-uniformity. It will guide the flow to the uh, guide the flow linearly to the compressor.
Okay. Now, have you seen the MiG-21 air intake?
Sir, pictures I saw, but I didn't see in reality, sir.
There is a cone, right? Cone will go
Yes, sir.
inside, outside,
Yes,
and
sir.
around the cone, intake is controlled. No amount of area around the cone is controlled. When a cone is fully retracted, more air will go inside the engine. When cone is outside, air is controlled. It will be less. Similar
Okay, sir.
that conditions are there, but in such a control is not there at all in LCA, right? Or there is nothing there for controlling
No,
the
sir, this
air.
is not there.
This is not there. Okay. What is the intake used in AMCA?
Sir, AMCA intake is rectangular, sir, like under the fuselage, under the wing, rectangular.
Under the wing, rectangular. Okay. But it is, when we see the papers which are coming out, they say it's using a serpentine intake and all. Is it so, or what is it?
No, so duct is rectangular, but in like front part of the cowl is the rectangular they are using, but they are using bifurcated serpentine intake duct.
Okay. What is the purpose of that?
Sir, bifurcated like two sides are there, and serpentines
Mhm.
like means they are increasing the volume for the fuel. That's why they are using serpentine and single engines.
Okay.
Sorry, not
Is
single,
it for
twin
the
engine.
fuel or is it for the, what is stealth?
So like stealth means they are kept reducing from the radar. Like when radar go inside duct, it will not go to the engine. So it will come back
Mhm.
without finding the engine. And we are using radar absorbing paint also inside the duct. So that some radar will go, it absorbed by the duct also.
So purpose is for the stealth, right? Okay.
Yes, sir.
Now, what is a turbojet and what is a turbofan engine?
Sir, turbojet is like a jet engine in which compressor, diffuser, compressor, combustion chamber, turbine, and nozzle is using. Turbofan is similar like to turbojet, but rather than turbojet, we are using one more thing, which is a fan, ducted fan.
Okay. How much is the bypass? What is the percentage of the air is bypassed?
Sir, bypass is in Mark 2, sir.
Hmm.
Uh, Not
For
sure,
example,
sir. I didn't.
LC Mark II, how much is bypassed?
I didn't check, sir. I'm guessing only 10:1. I didn't check, sir.
Okay, check those.
Okay, sir.
In what way LCA Mark II is different from LCA Mark I?
Sir, mainly it is like first is canard, sir. We are using canard, which Mark 1 is not having. And
Okay,
second is, sir, area ruling. It is more area ruled than Mark 1. And sir, third is we are using tip missile.
okay.
Uh, and sir, one more is on the intake point of view, intake is 900 mm shifted.
Okay,
And sir, length also increased, sir. And we are using the plug, like 500,000 mm plug we are using. So it will increase the fuel flow rate also, which will be helpful in the range and for range of increase the range of the aircraft.
right. What is the engine use? Engine is 404 or 414?
No, sir, engine is we are using GE 414, which is advanced
So
than the
that is
GE
that's a
404.
major difference, right? Okay.
Okay.
So now, what is the engine planned for AMCA?
Sir, AMCA still they are going for GF414, but is
Yeah.
not confirmed. Maybe sir, Japan also going for their giving the engine, so they are not confirmed for GF414. But still F414 is there.
Okay. What are the precautions to be taken for a single engine aircraft?
Precaution first is the thrust, sir.
Hmm?
Sir, thrust, I'm not sure, sir. I'm not.
What is the bird strike?
Burst strike, like when bird go inside the intake, so we have only one engine, so
Hmm.
not other engine to compensate with the fault.
So how do you protect the bird from going inside the engine? Theoretically, I'm telling.
So mainly they are using the
Hmm?
light they are using to avoid the birds.
No. If you are a designer to avoid bird injection into the engine, what will you do?
I didn't make the straight intake. I did make